Hello everyone, my name is Danish and you're watching Cornels. In this tutorial, we're going to learn how hooking works in C++. In programming, hooking is a technique which can be used to alter the behavior of a function. It is mainly used when we don't have the source code for a function that we want to edit. There are many types of hooks. The most common and cleanest type of hook is a trampoline hook. Let's say we have a function and we want to monitor it. To accomplish this, we will need to write a custom function where we will log the activity of the target function. We will allocate a small block of memory for the trampoline. Since the size of the jump instruction is 5 bytes for 32-bit applications, the first step is to copy the first 5 bytes or more from the top of the function depending on the instruction size, and then copy it to the allocated memory block. Now we need to place two jump instructions. The first jump instruction, which will act as a hook, will be placed at the top of the function, so it can jump to our custom function when it's called. The second jump instruction will be placed at the bottom of the allocated memory block. It will jump to the next instruction of the function after the hook. In the custom function, we need to call the original function without triggering the hook. We do that by executing the bytes on the allocated memory block. When the function is called, the call will be redirected to our custom function. The logging code will get executed and the control will jump to the allocated memory block. The jump at the bottom will redirect us to the original function. In this way, we will avoid executing the jump at the top and properly call the original function without crashing the program. Let's take a look at an example. This is the hooking code, but before I explain how it works, I want to first show you how to use it. This function is called whenever a DLL file is loaded into the process. By hooking this function, we will be able to log its activity. We can remove this. We can write our login code here. The login code is done. Now we need to somehow call the original function, and this is where the trampoline will come in. The reason we did this is because this will allow us to call the original function within the hook. Right here. Oops, I made a mistake. Alright. Okay, so now we can place the hook. Let's rename this. Oops, I made a mistake. For the hook size, we need to go to this address and then figure out what should be the hook size. So let's print the address. Okay, so we need at least 5 bytes. So 1, 2, 3, 4, and 5. So these 3 instructions will give us 5 bytes. So the hook size should be 5 bytes. All right. And we can also print this. Now let's compile our program. We can use a process hacker to inject our DLL file. Now this is a simple DLL file that will print hello world. And there you go. So it prints hello world, and you can see that it logs the path of the DLL file. Now we can analyze the code in Cheat Engine to see how it works internally. So we can go to the address of the function. The first thing that happens is that it jumps to our custom function. We can press spacebar here. This is where we log the function activity and then jump back to the original function. Now, this is where the magic happens, okay? Because this variable contains the trampoline address. So if we go to its address, here we can see the 3 instructions. These 3 instructions belongs to the LDR load_DLL function. So when this function is called, then these instructions are executed, and then this jump is taken and it will take us back to the original function. So as we can see, the first 5 bytes are not executed when we call this function. We can't use these first 5 bytes because they are used for the hook now. So when we call this function, we have to execute these first original 5 bytes separately. So this is why when we allocated the new memory block, we place these first 5 bytes here, and then we place the jump. And this jump takes us right here, so the program can continue executing the function. So this is why we call it a trampoline hook. Now we can go back to our main function and let's see how it works now. So the first thing we do is we get the base address of the DLL file, because this DLL file has this function. So once we get the base address, we then get the address of the function that we want to hook, and finally we hook this function. We are redirecting this function to our custom function. And of course, we supply the size of the hook, which is 5 bytes. And the return address is the trampoline address. And we assign it to original LDR loadll variable. This is our hook function. This function is responsible for setting up the entire trampoline and properly redirecting the jumps. So here we are allocating the memory for the trampoline. The first parameter is the address where we want to allocate. Since we supply 0, the system will decide where to allocate the memory. This is where we supply the number of bytes we want to allocate. I made a mistake here at the time of recording the video. This should be hook size plus 5 because we're also adding a jump at the bottom of the original bytes. The next parameter is the allocation type. This is where we set the page access. The execute permission allows us to execute the code, and the read and write permission allows us to read and write from the address. And then we copy the bytes from the target function to the trampoline address. So basically we are, as you can see right here, those are the bytes on the trampoline here. These bytes are actually copied from the original function, from right here. So we are copying the bytes from the target function to the trampoline. This code will place a jump at the bottom of the bytes. So if I go to this address, you can see there's a jump right here. So these are the instruction bytes, the original instruction bytes, and this is the jump. So this code will place this jump, and if I press spacebar here, you can see that it will take me to this instruction, like right after the jump instruction. And of course, this one is very simple. We are placing a simple jump here, this jump. This code will place this jump on the function, like at the top, and it will redirect us to our custom function where we have our login code, this function. Now, this code might look complicated, but trust me, it's not. If you look at the first parameter, it is the jump instruction array. So we can see that the size of the array is 5 bytes. That's because the size of the jump instruction is actually 5 bytes. So if you go to this address, we can see that this is basically a long jump, okay? And if we count the bytes, we can see 1, 2, 3, 4, 5 bytes. The first byte is the opcode, which is E9 in hexadecimal. This is the opcode. The first byte is the opcode. So these last 4 bytes are the relative address where we want to jump to. So these last 4 bytes contain the relative address. This function has a very simple purpose. Using virtual protect will allow us to set the right access. Without the right access, our program will crash because this function is located in NTDLL, and this means we must set the right access. If it's not there by default, the program will crash, obviously. So we set the right access, we copy the bytes, and then we restore the old protection. And yeah, that's all. That's all you need to know about the trampoline hook.